In this tutorial, we will be discussing the different types of solids. In solids, the particles are packed tightly together. This results in solids being incompressible and having high density. The particles have no translational or rotational freedom of motion, which results in the solids retaining their shape and volume when placed in a new container. It also prevents the particles from flowing from one side to another, such as a liquid does. There are two types of solids. There's crystalline, and then there's amorphous. Crystalline are orderly geometric patterns, such as salt or diamonds, whereas amorphous solids have a non-regular geometric pattern over a long range, such as plastic or glass. We're going to be focusing more on crystals. Crystalline solids classifications can be based upon the particle makeup or the types of attractive forces holding the particles together. The first one we're going to discuss are molecular solids. These are solids whose composite particles are molecules, such as ice, which is composed of H2O. Ionic solids are solids whose composite particles are ions, such as table salt, sodium chloride, which is composed of sodium ions and chlorine ions. And then there's atomic solids. These are solids whose composite particles are atoms. Non-bonding atomic solids are held together by dispersion forces, such as the noble gases. Metallic atomic solids are held together by metallic bonds. And network covalent atomic solids are held together by covalent bonds. For example, graphite, which is what you find in your pencil, is an example composed of carbon atoms for the network covalent atomic solids. So let's go through an example. KCl is an ionic compound, so its solid classification is ionic. Carbon in the form of graphite is made of molecules bonded together, of covalent bonds. So therefore, it's considered network covalent. That should not be there. So when we're looking up here, it's an atomic because it's just carbon, but it's a network covalent of atomic. Krypton, which is a noble gas, is considered an atomic classification because it's just one atom there. Strontium chloride is ionic once again. Silicon dioxide is once again considered a network covalent. But instead of being atomic, it's actually molecular. H2O is molecular. S8, because it's only one atom here, one type of atom, it's still atomic, but it's molecular atomic. Cu is copper, which is metallic. And finally, Na is sodium, which is once again metallic. And that is the different types of solids.